Now in the part B of this lecture, we have discussed the effect of structure of the substrate on SN1 reaction. And I told you 3 degree will favor SN1 reaction. Then it depends upon the stability of a carbocation. And the stability of carbocation was directly proportional to the number of resonating structure, was directly proportional to the number of hyperconjugating structure, was directly proportional to the plus I effect, and was inversely proportional to minus I effect. I told you that vinyl and aryl carbocations are unstable. So vinyl halide and aryl halide does not show SN1 reaction. Apart from that, if on the heteroatom, that is at the beta position, if on the heteroatom the lone pair of electrons are present, which is in a conjugation to the carbocation, that will favor SN1 reaction. And if at the beta position quaternary or tertiary groups are present, that also favor SN1 reaction. Now to the second effect, that is the effect of solvent for SN1 reaction. That is, how does the solvent affect SN1 reaction? Now effect of solvent, remember, polar protic solvent like water HOH, alcohol ROH, formic acid SCOH, or any other acid, it favors SN1 reaction. The question arises, what are polar protic solvent? Remember, a very conceptual part. If in any solvent hydrogen is bonded to electronegative atom like oxygen, as you see over here in water, like in alcohol, in acids, etc., all those solvents are called as a polar protic solvent. So what are polar protic solvent? The solvent in which hydrogen is bonded to a electronegative atom. If any reaction is carried out in a polar protic solvent, which generally are the weak nucleophiles, this will stabilize the carbocation and its counter halide and hence favor SN1 reaction. As for example, we take 2-chloropropane, just see over here. In 3 degree what mechanism? SN1. In 1 degree what mechanism? SN2. But in 2 degree we have to decide whether SN1 or SN2. In 2 degree haloalkanes, when the hydrolysis is carried out in presence of HOH, what is the nucleophile over here? OH negative. But this OH negative is bonded to proton or H. So what type of a solvent it is? A polar protic solvent. So it will follow what mechanism? It will follow SN1 mechanism. So this Cl group will be substituted by the nucleophile OH and this will result in the formation of a propane 2-ol or secondary alcohol. So the reaction is taking place in presence of polar protic solvent. So what mechanism of the reaction? SN1 reaction mechanism. What will be the intermediate? It will be a carbocation. Similarly, see over here, if we carry out the reaction of this is a 2-chloropropane and we let it react with alcohol. Now, what will be the nucleophile over here? RO negative, alkoxide. This O negative is bonded with H. So, what type of a solvent is alcohol? It's a polar protic solvent. What will attack? O. So, it will attack on the secondary position and will result in the formation of a ether. You may see over here, the haloalkanes are resulting in the formation of alcohol. Here alloalkanes are resulting in the formation of ethers. This we did in the chemical properties of a haloalkanes. What mechanism? SN1 type of a nucleophilic substitution reaction. How, although it is a 2 degree haloalkanes, so how do I decide whether it will follow SN1 or SN2? Remember, 3 degree always follows SN1. 1 degree always follows SN2. 2 degree may follow SN1 or SN2. It's a comparison between SN1 and SN2. So if on the 2 degree haloalkane, the reaction is being carried out with a weak nucleophile in presence of a polar protic solvent, then it will always and always be a SN1 reaction mechanism. What are polar protic solvent? All those solvent in which electronegative part is bonded to hydrogen atom, like in water, like in alcohol. So second factor which affect the SN1 reactions are the effect of solvent. What do we conclude from here? Polar protic solvent will favor SN1 reaction. Naturally, aprotic solvent will favor SN2 reactions over here. Now the third factor is the nature of the leaving group. This is very important factor which affect SN1 reaction. Remember, stronger the nucleophile, that is the basic character of the leaving group, more will be the favorism for the SN1 reaction. How do we do this? Just see over here. If you compare this one, if you compare the leaving group, of course in the haloalkane the leaving group will be halo group. It will be iodide, bromide, chloride and fluoride. So increasing basicity, if you go with this, so increasing basicity will be iodide ion is less basic as compared to bromide ion, as compared to chloride ion and as compared to fluoride ion. You may ask, so how do we know that iodide is a weaker base as compared to bromide, chloride or fluoride? We have in the class 11 done with you a concept that strong acid have a weak conjugate base and vice versa. Now if we look at the acidic character of halo acids, always remember HI is stronger acid as compared to HBr, as compared to HCl, as compared to HF. Why? Because the size of iodine halo atom is greater than bromine, chlorine and fluorine. So this bond may break easily and may release proton. So hydrogen iodide is a stronger acid as compared to hydrogen bromide, as compared to HCl, as compared to HF. Now HI after losing a proton will form a conjugate base. Which base? Iodide ion. Here HBr will form bromide ion, chloride ion and then a fluoride ion. Now HI is stronger acid, so its conjugate base will be weak. So strong acid have a weak conjugate base and nucleophilicity parallels basicity. So naturally increasing order of basicity will be iodide will be a weaker base as compared to bromide, as compared to chloride, as compared to fluoride ion. So over here, what will be the decreasing reactivity towards SN1 reaction? Alkyl iodide. Alkyl iodide is a better leaving group. Why? Because iodide is a weaker base over here. So this is decreasing leaving group ability. Iodide is stronger as compared to bromide, as compared to chloride, as compared to fluoride. So alkyl iodide will show faster SN1 reaction as compared to alkyl bromide, which will show faster SN1 reaction as compared to chloride, as compared to fluoride. As for example, if the question is asked, this compound over here, suppose we write down, this is CS3 and then C and then CS3 and then CS3 and then over here is I and then another one over here is CS3. This will be C, CS3 and CS3 and Cl. And if I ask you which of the two shows faster SN1 reaction, suppose is it made to react with OH negative. Here again it is made to react with OH negative. This is first and this is second. If I ask you which of the two is faster for SN1 reaction, so naturally iodide ion is a better leaving group as compared to chloride ion. Why? Because iodide was a weaker base as compared to chloride ion. So first will be faster than second. You can almost be assured in the board examination out of these concepts, that is the structure of solvent, effect of solvent and the nature of a leaving group. For SN1 type of a reaction, you can get 2 marks question in the board examination. And normally these kind of a question are asked, which of these groups will show faster SN1 reaction. So as far as the factor affecting the SN1 reaction, we have done with you the structure of substrate. What concept? It depends upon the stability of carbocation. So more the number of resonating structure, more the stability of carbocation, more will be the favorism for SN1 reaction. So we have done with you triphenyl carbocation was more stable as compared to biphenyl carbocation, which was more stable as compared to allyl carbocation, which was more stable as compared to 3-degree carbocation, more stable than 2-degree carbocation, which is more stable than 1-degree alkyl halide carbocation, which was more stable than the methyl carbocation over here. And the stability of carbocation was directly proportional to number of resonating structure, directly proportional to number of hyperconjugating structure, directly proportional to plus I and inversely proportional to minus I effect. Polar protic solvent favors what type of a reaction? SN1 reaction. What are polar protic solvent? All those solvent in which electronegative part is bonded to hydrogen. Then strong nucleophile favors SN2 weak nucleophile favor SN1. What are weak nucleophile? All those nucleophiles in which H is bonded to electronegative atom. Then, depending on the nature of the leaving group, more is the ease with which leaving group can leave the haloalkanes, more will be the reactivity for SN1 reaction. So, iodo compound will be more reactive as compared to bromo compound, as compared to chloro compound, as compared to fluoro compound. And how do we decide the increasing basicity order? Strong acid have a weak conjugate base and vice versa. And always remember, nucleophilicity parallels basicity. Hopefully you understand what are SN1 reaction and what are the various factors which affect the SN1 reaction and what various types of questions can be asked. Now we proceed ahead from here. That will be stereochemistry of SN1 reaction. Try to recollect. I told you what are chiral carbon atom or chiral carbon atom, as some people pronounce it as, although the right word is chiral. It has been taken from the Greek word which is K-I-R-A-L. So it shall be pronounced as chiral. So chiral or chiral carbon atom are those carbon atom in which carbon atom is bonded to 4 other atomo group. Just see this compound 2-bromo butane over here. In this case, this carbon atom is bonded to this Br, H, methyl and ethyl group. So this will be a chiral carbon atom. And any compound which have only one chiral carbon atom is always optically active. What are optically active compound? Those compounds which can rotate the plane polarized light either toward the right side or towards the left side. All those which can rotate the plane polarized light toward the right side were called as dextro-rotatory isomer, and those which rotate the plane polarized light toward the left side were called as a labio-rotatory isomer. Hopefully you remember that dextro means rotation towards the right, labio means rotation towards the left. If the plane polarized light is passed through the organic substance. Now about the stereochemistry of SN1 reaction. Just see over here, this is a 2 degree compound over here. Now in this compound, this carbon atom is chiral. Chiral means it is optically active. That means it can rotate the light either toward the right or toward the left. Now if it is being attacked by the nucleophile, OH negative, what does the stereochemistry means? This OH negative ion can substitute this Br group over here, but it can attack this chiral center either from the frontal side, that is the frontal attack, or from the rear side. Rear means back side. So it will either have a rear attack or it will have a front attack. If this OH group substitute the Br by frontal attack, naturally this Br bond will be broken and OH will be substituted over here. And if it attacks from the back side, naturally the OH group will come to this side. Just see over here, there are 2 probabilities. OH attacking from the same side, so OH coming over here. OH attacking from the back side, so OH coming over here. The concept will be applicable only for the chiral carbon atom or chiral carbon atom. Now, the stereochemistry of SN1 reaction is whenever the nucleophile attack the chiral carbon atom, chiral carbon atom, the product will be a racemic mixture, and the process is called as the racemization of configuration. What does it mean? It means, just see over here, this OH group is towards the right. Now, I don't know whether it will be rotating the light towards the right or towards the left, but there is a certain way which will help us to understand whether it will be rotation towards the right or rotation towards the left. I am not saying it is dextro or labio. I am saying the rotation towards the right or rotation towards the left. So that configuration has been given in terms of R and S form. R means rectus. Rectus means towards right. So rectus means towards the right side rotation. And S means sinister. And this sinister means towards left. So how do we decide whether this will rotate the light towards the right or towards the left? We have last year done E and Z system of nomenclature, where we did the priority rule or the seniority rule. And what was that rule? The atom group with the higher atomic number were given the higher priority. Just see, assign the priorities to the atom group attached on the chiral carbon atom. Here oxygen is attached to this carbon. What is the atomic number of oxygen? 8. Then what is the atomic number of carbon? 6. This is also 6. This is also 6. So next atom will be considered. Its next atom is hydrogen. its next atom is carbon. So this is number 1 and this will be number 2. Now look in the descending order of the priority. Look over here. This is a clockwise rotation. And in the clockwise rotation, the form will be called as a rectus form, which will mean the R form. So here, the rotation is toward the right. But there is one rule in the chemistry which is called as the golden rule. If the least priority group, its atomic number was 1, it is number 4. If the least priority group is present on the horizontal axis, then change the configuration from R to S or S to R. So here, this is 1, this is 2. Rotation is toward the right. So what configuration is coming? R. But since the least priority H is on the horizontal axis, so R will change into S. So what type of a configuration is this? This is S form. I think I should be very clear. Similarly over here, assign the number. This will be 1, this will be number 2. If you look in the descending order from 1 to 2, what rotation? It comes an anti-clockwise rotation. So this will be what form? It seems to be a left side rotation. But again over here, the least priority group, this is H, whose atomic number is 1, is present on the horizontal axis. So configuration will change from S to R. So what is this configuration? S. What is this configuration? R. So half of the molecule will rotate the light towards the left. Half of the molecule will show the rotation towards the right. So it is a mixture of enantiomers which are equimolar. What do I mean? That neither the rotation will be observed to be the right, neither the rotation will be observed to be left, and when no rotation is observed in a chiral compound, that means enantiomeric mixture will be optically inactive mixture. So here this was optically active compound, but this is a racemic mixture which will be optically inactive because of the expected 50% rotation towards the right and 50% rotation towards the left. So stereochemical aspect of this says that whenever a carbon atom on which halo group is present is a chiral carbon atom and it follows a SN1 reaction mechanism. Suppose it follows SN1 reaction mechanism, then in that case over here the product will be racemic mixture that will be optically inactive compound. But then an experimental observation say, although as per the concept over here, the mixture of the two enantiomers, these are the enantiomers, fine, the mixture of the two enantiomers should be the racemic mixture in the ratio proportion of 50:50 or 1:1. But experimentally it is found to certain extent the inverted forms are slightly dominating. So we will say, although the answer in the board examination will always be given as racemic mixture, but to be very precise in chemistry, it will be towards slightly more towards the inverted product. But one thing is to be noted, this is no complete stereochemical inversion. We cannot say that it is an inverted product. Although more percentage of inverted product will be formed, but quite a good percentage of other form will be formed. So that is why we will say there is a retention in this case, there is an inversion in case. So we will go with the concept that is a retention of a configuration and the product obtained will be racemic mixture which will be a optically inactive mixture. So is it I think it must be very clear. When SN1 reaction takes place on a chiral carbon atom, the product will be a optically inactive product and that mixture will be called as a racemic mixture. What is racemic mixture? An equimolar mixture of the two forms which neither rotate the light toward the right side nor rotates toward the left side and is optically inactive product over here. This is again a 2 marks question in the board examination if it is asked. What type of a product will be obtained? Decimation, a straight away question. What type of a product will be obtained if a SN1 reaction is carried out on the chiral carbon atom or chiral carbon atom? You will say it will be a racemic mixture which will be optically inactive mixture. Why racemic? Because half of the molecule will rotate the light towards the right, whereas a half of the molecule will rotate the light towards the left. So it will be S and R form. This is a right concept, fine, which is being done over here to explain the stereochemical concept of a SN1 reaction. So I expect you are very sure what do I mean by the stereochemistry of the SN1 reaction over here. Now, sometimes, remember, in 3 degree alkyl halide, answer will always be SN1. In 1 degree alkyl halide, answer will always be SN2. But you will find a problem solving the question related to 2 degree alkyl halide. How to differentiate whether on the 2 degree alkyl halide mechanism of the reaction will be SN1 or SN2. I have given one example over here. This is 2-bromo 3-methylbutane. The C over here, this bromo group is attached on 2 degree carbonate. So this bromo group is attached on 2 degree carbonate. Then I carry out the nucleophilic substitution reaction. You see, the attack is being carried out OH group over here. Your OH negative over here. Now, if SN1 intermediate is carbocation, SN2 we are yet to discuss, but there is no intermediate. They result in the formation of a transition state. This OH negative is a strong nucleophile. Observe over here. See very carefully. OH negative is a strong nucleophile. Why? Because this O on one side is not bonded to H. So it is a strong nucleophile. Here in this case, if it is bonded to H, it will become a weak nucleophile. As I discussed in this case also over here. So when on 2 degree alkyl halide, nucleophilic substitution reaction is being carried out by strong nucleophile. So this bond will break and OH group will substitute. And mechanism of the reaction will be SN2 reaction mechanism. Take it very, very carefully. In SN2 reaction, although it will be discussed in the next lecture, carbocations are not the intermediate. And when carbocations are not the intermediate, so there is no possibility of a rearrangement in this case. So it will always and always be the substitution at that position where the halo groups are removed. But if it would have been SN1 reaction, and how do we know it will be a SN1 reaction? When the nucleophilic substitution reaction is carried out in presence of a weak nucleophile. Here OH negative is a strong nucleophile. Water is a weak nucleophile. Why? HOH. It will attack through here, but this is bonded to H. So this kind of a nucleophile will be called as what? It is a weak nucleophile. Weak nucleophile for 2 degree alkyl halide will favor what mechanism? SN1 reaction mechanism. And for SN1 reaction mechanism, what are reaction intermediate? Carbocation. And what is the stability order for carbocation? 3 degrees more as compared to 2 degree as compared to 1 degree. Now look over here. This is 2 degree alkyl halide. If this Br bond is removed from here, it will result in the formation of intermediate, which is 2 degree carbocation. But if we shift this hydrogen from here to here, this will be called as the 1,2 hydride shift. 2 degree carbocation will change into what? 3 degree carbocation. Just see carefully. It's a 2 degree carbocation. There is 1,2 hydride shift and result in the formation of 3 degree carbocation. Since the reaction was carried out with a weak nucleophile, intermediate will be carbocation. Stability order 3 degrees more as compared to 2 degree as compared to 1 degree. So in the next step, what will happen? Now OH negative ion will attack over here and the product will be 3 degree alcohol. Just see the difference over here. With the case of a strong nucleophile, 2 degree alkyl halide gives 2 degree product. But with the case of weak nucleophile, 2 degree alkyl halide, when there is a possibility of a rearrangement, that is moving toward the more stable carbocation, then the more stable carbocation will be the intermediate and that will result in the formation of a desired product. So here the answer obtained is 3 degree. Here the answer obtained is 2 degree. In the board examination, it will be asked in the straightforward manner. They will be writing this reaction over here and then writing over here in presence of HOH. It is a weak nucleophile. They will be asking, what will be the reaction intermediate? 3 degree carbocation. In this case, what will be the reaction intermediate? 2 degree carbocation. A very quality concept has been discussed with you, which many of the students are not aware with. We have been doing completely what is in our syllabus. That is the SN1 reaction mechanism. Please be very sure with the concept. In SN1 reaction, the product obtained will be racemic mixture. When we discuss the stereochemical part of this, racemic mixture is optically inactive. Why? Because of a equimolar mixture of a enantiomers. That means there will be retention as well as a inversion of a configuration. And when the nucleophilic substitution reaction is being carried out in 2 degree haloalkanes, in presence of a weak nucleophile, it will be SN1 mechanism. In presence of a strong nucleophile, it will be SN2 reaction mechanism over here. So I told you that nucleophilic substitution reactions are in the first part of this lecture. I told you nucleophilic substitution reactions are SN1 or SN2. We started with the discussion of SN1 reaction in the first part, and I told you SN1, that is a nucleophilic substitution reaction of the first order. The rate of reaction is directly proportional to substrate. Intermediate of the reaction was carbocation, because the step in which carbocation was formed, that was supposed to be a slow step. How do we come to know it was a slow step? Because of a high activation energy barrier. Then we discussed what are SN1 reactions, how does the effect takes place. First was the structure of the substrate, second was the effect of the solvent, third is the nature of the leaving group. Effect of substrate is very clear. It goes with the intermediate carbocation. Stability of carbocation is directly proportional to number of resonating structure, which is directly also proportional to number of hyperconjugating structure, directly proportional to the plus psi effect, inversely proportional to minus psi effect. If the beta carbon atom is tertiary or quaternary, then that haloalkane also show SN1 reaction. If the next to the halocarbon atom, the heteroatom is present, that will also favor SN1 reaction over here. Vinylic and aryl halides never show SN1 reaction because vinyl carbocation and aryl carbocations are unstable in nature. Similarly, effect of solvent, polar protic solvent favor SN1 reaction. What are polar protic solvent? Those solvent in which electronegative part is bonded to hydrogen. Nature of the leaving group. Then I told you iodo compound reactions will be faster as compared to bromide, as compared to chloride, as compared to fluoride, because iodide ion is a better leaving group as compared to bromide, as compared to chloride, as compared to fluoride. What concept do we apply? Strong acid have a weak conjugate base and nucleophilicity parallels basicity. Stereochemical part, the product will be racemic mixture. There will be retention as well as inversion of configuration. And in the 2-degree case, with a weak nucleophile, there will always be rearrangement if required and will be following SN1 reaction mechanism. With a strong nucleophile, it will follow SN2 reaction mechanism. A very basic concept of this chapter has been done. This chapter entirely revolves around the 2 major concepts or 3 major concepts. This is nucleophilic substitution reaction, elimination reactions. This nucleophilic substitution reaction can be SN1 and SN2. SN1 type of a nucleophilic substitution reaction has been done with you. In our next lecture, we'll try to go with SN2 reaction. Remember, we are doing chemical properties of haloalkanes and haloarenes. First property was the reduction reaction. Second was reaction with metal. Third was nucleophilic substitution reaction. And this time, we are discussing the concept of a nucleophilic substitution reaction. It can be SN1 or SN2. SN1 type of a nucleophilic substitution reaction has been discussed with you in this lecture number 10. Hopefully you understand. Go through the concept very conceptually. If you apply this concept, I assure it cannot be possible that you won't be able to solve the questions. Any question from any book can be solved out. Please try it out. Thank you.